Hey, good morning, everyone. Welcome to Introduction to AI Engineering. I've got Pavan on the chat here. So let's see, who else do I have here today on the chat? We are going to start in just a second. Okay, perfect. I got 9 people here on the chat. So hello, everyone. And if you don't have this stream open up on your laptop, you can actually open it up on your laptop. My YouTube channel is right here. It's youtube.com/James Merza. And it's important if you have this open, because if you have this here open, then you can send in comments over the chat, and then I can answer your questions as we go along. Pavan, can you just text me? Okay, perfect. I see that I'm audible. So that means that we're good to go. But if you're watching this and you have this, and you're one of the few people that has this open on your laptop, please send me a comment right now through the video, and tell me your name and tell me you're watching. The workshop is going to be a lot more fun if we have people commenting in. Good, got a few more people joined just now. If we have people commenting in live and telling me how it's going. Great. So, what are we going to learn today? It's an introduction to AI engineering. I'm James, and I'm here today with a couple of my puppy programmers. This is Cooper, and we have another one in the back. Let's see, is Minnie back there? He's more of just a spectator, but Cooper likes to actually touch on the keyboard sometimes, so he might be helping me out. But the three of us here are going to be coding through the basics of AI engineering. And what that means is that we are using our Python programming skills. Great. Good to see you, Sumit, in the chat. Good to see some people here. Good morning. We're going to be using our Python programming skills combined with a fundamental knowledge of how LLMs work to write some programs that are using LLMs. And we're gonna put some building blocks together, so how we can make generative AI applications. Now, we're not going to be doing a full stack application today. We're just going to be doing Python backend, and then you can later work that into all of your other programming skills that you have to make a full stack application. How does that sound? Is everyone good to go? As I think you know, for this workshop, there's going to be a couple of things that you're going to need to use, and those are free accounts that everyone has, and that's a Google account to use Google Colab, and a free OpenRouter API key. Now, there's 2 ways to participate in this workshop. You can code along if you want to, or you can just watch. This is meant to be more of a discussion, more of a conceptual course on how things actually work. If it's too much to be running the code at the same time, that's fine. Just follow along, and we'll be working our way through. We'll be working our way through the concepts. All right. So the code that I have here in this document is actually, I'll just scroll down to the first code example here. is actually complete code that you can copy and paste into a Google Colab notebook. So let me just show you real quick how that works. So let's say you have, and we're going to do that by, we're going to go through these prerequisites real quick for those who don't have it already. So I'm guessing you have a Google account already. So you'll just go to Colab. You can search for Google Colab, or you can go to colab.google.com, and you can just create a new notebook. All right, and you can run this in your in VS Code, in whatever IDE you have on your desktop, but you'll have to change a couple of things for that to work. So I'm just going to use Colab here. Now, what you probably don't have already is an Open Router account, and we'll get back to that in just a second, what Open Router is. But to get that API key, that free API key, which is going to allow you to run LLMs for free, you need to go to openrouter.ai. You need to go to keys here on the side, and you need to create a new API key. And this is entirely for free. You shouldn't have to put in your credit card to do any of this. So once you have that, I'm just going to show you real quick how you can get this code running. So you would go to let me send you here the URL of this notebook, in case you don't have it. So this is the URL of the notebook. It's github.com/JamesMerza/intro to AI engineering. So you would be able to copy and paste. Just click this copy button, and then you'll go to your notebook, your notebook here. Paste here, and now you need to go to the key button here on the side. It says secrets. All right. And under all of this, you'll do add new secret. And you can actually just copy this Open Router API key, paste, and then you're here in this one, you're going to paste the API key that you got from Open Router here. So you'll do create API key, click create, it'll give you a key, and then you're going to paste that in here. I already have that, okay? And just to show you what happens, hey Harsh, glad to see you, hope you're following along today. Just to show you what happens when that runs, we're going to click run, and if all is well, we'll see the output of the code. Might have to click grant access here. So that's just a quick run through of everything you need to know to run the code in today's workshop. I'm not going to make you run it all from scratch or to type it all out, but just to show you how it works. Okay, so try that now. If you have any trouble with that, either ask the person sitting next to you or write a comment in the chat, and we'll figure it out what's not working. But with all of that said, and Pavan, you can also text me if there's anything that you want, any direct questions you want to ask to me. But with all of that said, let me go back to the document, and let's start at the beginning, and let's talk about AI engineering. AI engineering is sort of a term that was made up a couple of years ago, or reintroduced a couple of years ago. Perfect. Okay, everything's working. Let me know if you run into some hiccups with the code along part. But this term basically is just a combination of software development skills and LLM skills. So everyone here has used LLMs, as far as I'm aware, and um, there's so much going on every single week. Every time I teach a workshop, there's new LLMs. There's new LLMs that have been introduced, upgraded, new skills, new benchmarks, new headlines. So there's a lot to follow up on, and right now, um, I'm going to talk about how I'm going to talk about a little bit just how for any given LLM, how that works and how those are created. An LLM is a machine learning model, right? Um, and what we need to know in order to work with them is basically just that that it's a model. It's trained on a lot of text, and it's normally trained in a few different phases. All right, but the most important thing to understand is that it has a huge amount of parameters. All right, so it has typically the ones that are commonly used in production have billions of parameters. Those are floating point numbers that are tuned as the model is trained on terabytes of information. So, in order to, without going into the details of what is the exact architecture of what is the exact neural network architecture of an LLM, and there are multiple, the really important thing for us to realize is that there's a huge amount of data and a huge amount of parameters, and that gets trained in several phases. And once the training is finished, what you end up with is this incredible machine learning model where, and if I go to OpenRouter, I can actually do a demo of any of these models. So let's take Llama, because we're going to be using Llama today, Llama 4 Maverick. And what you end up with is this incredible model. This is not a free one. Let me search for the free one. Which can complete text, it can respond to text, and it can correct text, it can write code, it can solve problems, it can do all of these things. And the way that we get there, given an LLM architecture, is through a few different phases. The first phase consists of taking a ton of unstructured text from the internet, so just raw websites, books, encyclopedias, every piece of text that we can find, or that the company that's training the LLM can find, and then using basically a kind of unsupervised learning to teach the model how the structure of language works. And then the second part of the training is called supervised fine tuning, and that teaches it more what is a proper response to a text that's given to it. So this trains it where the first type of training is just text without any structure. The second phase structures it into questions and answers. And then finally, the third phase of training is helps to tune the way that it speaks, tune the style of the output. And if you think about how ChatGPT speaks to you, it always sort of speaks in a unique particular style, which is really recognizable. And that's actually trained by people who are paid by the company training the LLM, who actually use reinforcement learning to train that model. Now, I think that's enough of me talking about how LLMs work for now. I just wanted to give a brief overview of the fact that there's a huge amount of data that goes into training LLMs, and I think that's often that can be a little bit easy to overlook um, how much data is necessary. And when we start looking at, and when we want to explain almost anything about the behavior of the LM, we can look back at the data that went into the training process. There's just a question here which says, since LLMs are prone to give hallucination at times, how do we generally overcome that? Yeah. Great question. So hallucination is usually what it means, um, is that um, the is that it's coming up with something that does not exist in the training data. Um, it's sort of it's sort of like overfitting problem in machine learning, and I don't have an easy solution um, to to mitigating hallucinations. Um, this is this isn't something that I have a great answer to in general. Um, you really have to use many different techniques in order to solve this. Sorry, uh, I don't have a better general answer to this. You can look at the data that it was trained on. You can add some techniques at the end to maybe link back to sources. You can use retrieval augmented generation to feed in data while the LLM is being called to feed data directly into it that's relevant. So these are all these are all techniques that can be used for hallucinations, but you really have to look at your problem in context, the specific problem that you're having in order to solve hallucination. There's no general solution to it. Someone just asked a question. What is uh, Someone just asked the question, what is AI? Okay, great, great question. So let's just look at the definition of artificial intelligence. Um, it's if we look at the definition here, we'll see it's basically the ability of computers to do intelligent tasks that humans would otherwise be doing. Now, one just thing that I'd like to point out that I think is um, easy to mix up when you are new to this is the difference between AI and machine learning. So um, there are many types of computer programs which are AI. Machine learning is one particular subset, is one particular approach to artificial intelligence, which uses large amounts of data to train a model. But it's possible to create models, for example, hard coding models. For example, if I hard code a tic-tac-toe algorithm, that's also considered artificial intelligence. Or if I would create a simulation, maybe uh, of a population or of the weather, you could also consider that possibly artificial intelligence. So it's extremely broad. Um, it's an extremely broad classification. Great. So let's move on. That's just a bit of theory. Let's move on to a little bit more about LLMs concretely. Okay, so um, so basically, I just want to show you a couple of links here. This is a tokenizer, and um, you can use this to see how LLMs break up text um, in order to understand and parse the text that's fed to them. So let's take this text here and let's put it into the tokenizer, and you'll see that each of these words, and sometimes a character, and occasionally a part of a word, um, is broken into a token. And this is how LLMs understand text and language. And you'll also see, if I would write code here, this is also how it also just sees this text as language as well. And this is a token, and this is a token. So before an LLM is called and after the LLM is called, there is a step. There is a tokenization step, which converts any string into tokens. And afterwards, the tokens are converted back into a string. And this is just sort of a way of compressing information into a way that just it makes more sense, and allows the LM to focus on what's meaningful. So this is a really handy tool to help understand what's going on. And here's a fantastic video from 3 Blue 1 Brown, which goes into um, which goes into detail about how LLMs work, and explains much more gracefully than I have, with a lot of visualizations, the mathematics behind LLMs. Now let's talk real fast. Let's talk real fast about the different LLMs that are available. And like I was saying at the beginning, there are so many there's so many new releases all the time. If you go to Hugging Face and you click on models, and then you click on let's look at text generation models here, and this is just one type of LLM here. You see there's 230,000 text generation models. These are just open source models that you can download from Hugging Face. So there's so many. And if I sort by recently created, you see, the last fine-tuned model was uploaded 5 minutes ago, 6 minutes ago, 20 minutes ago. It's a really quickly growing field. And we can also, of course, it's also really important to be able to compare LLMs for the particular purpose that you might have, that you want to use them for. And so to do that, you need to come up with some kind of ranking, some kind of system. Now, you might have to create your own way to compare LLMs. There are a few great resources out there. Mm-hmm. Oh, and someone just asked a great question, which is, what are the good LLMs for low-end devices? Because today I'm going to be talking about LLMs, the more high-powered LLMs for high-end devices. So let me just talk about comparing LLMs real quick. So we have this great resource here called Chatbot Arena. And Chatbot Arena, just click OK when you get here, and then go to leaderboard, is a constantly updated leaderboard of all of the open source and closed source LLMs that are available out there. and it uses crowdsourced data. So I can go here, and I can actually put in a prompt here, right, and say, who's the president of the US, right? And I can see the output of this. And if, let's say, these are both wrong, but let's say one is wrong and one is right, I could, oh, so here I can say both are bad. I could say one is better. And so here I'll say both are bad. And so this, um, this is, I'm just one of thousands of people who are playing this game, and all of that data goes into the leaderboard, and so we can see which ones are the best according to the users of this website. So this is a really, really, really useful tool to see today which LLMs are ranking the highest. Someone asked, "They are. This all are completely free." No, this combines proprietary and open source models, but the ones we'll be using today, Llama, will be free. Someone just asked. Someone just said, "Will AR take our jobs?" No, I'm not. I'm not ignoring your question, but to be honest, the answer to that depends on maybe how much you pay attention during this workshop. So that's more up to you than it is up to me. And then someone asked, how does the tokenization work for the LLMs? Oh, that's a really great question. In general, the tokenization. Let me just open that up real fast. So as you can tell, like it's just a mapping here. So if I do the same text twice, it is actually getting tokenized the same way. So you can think of tokenization as just a map of strings, and then you can think of this here as having basically a number, of each token of having a unique number, and there's a process. There's a process by which by which they decide what these are, but that's a little bit more complex. But yeah, as far as you're concerned, it's literally just a mapping of strings to yeah, unique tokens. So yeah, that's most of what I wanted to say about LLMs. This is another really great resource for comparing LLMs on more difficult tasks, but we won't get much into that today. Let's get into writing some code, because we have a bit over an hour left, and yeah, I'd love to start giving you some code that you all can actually use in your projects. Yeah, has anyone here worked on some cool projects using LLMs? I'd love to hear what you've made, or what you're working on, or what you'd like to make. So this here shows the simplest building block that we're going to start with, which is we take a prompt, and we pass that to the Llama API, which is hosted on OpenRouter with the API key that we already have, and that's going to output some text. So let's look at the code here. So this code, as I've showed you before, I have pasted it here into Colab, and I click run. So what we got from that is, okay, so the question here, um, what's the meaning of life? Okay, let me choose something more interesting. How old do sea turtles grow to be? And so this format here is the message, is sort of like a chat history format that gets passed into the LLM API. And this is a llama. I think you don't have. Correct me if I'm wrong. I think you don't have llamas in India, right? There's not many in the U.S. either, but this is a llama because we're using a llama. We're using Llama, the open source LLM trained by Meta, for this example, and specifically Llama 4 Maverick. So let's start at the top here. So this first line, it's specific to Google Colab. It allows us to read the secrets that we've put here in the left-hand sidebar. The second line imports the OpenAI SDK. Now, we're not actually using OpenAI. We're using OpenRouter, which is a completely different. It's a completely different host, and actually, we're not using GPT either. So why am I importing code from OpenAI's library? Well, the short answer there is that OpenAI created this library initially to interact with their own APIs, but shortly after, it became the standard for almost every other LLM provider, not Anthropic and not maybe a couple of others, but almost everyone else has adopted the same standard as OpenAI, which makes it really easy. All we have to do is change this URL here, and that's it. And so we can use, if we would take this out, we would be needing to put an OpenAI API key here, but with it in, we can use any other LLM provider. Oh, yeah, I forgot to answer a question actually. So someone had asked a great question about which LLM is best for low performance models, and I'm so sorry I forgot to answer that. So I would so the best way to think about it is that the more parameters that your model has, the more memory, the more GPU, and the more power that model is going to use. So if we look here on OpenRouter and we look at the different models that are available, now of course if you're using an API, it doesn't matter what device you're calling it from, because it's just making an HTTP request. But if you're actually talking about running an LLM locally, like I don't know, maybe we wanted to run an LLM on a Raspberry Pi, then you would need to look for an extremely small one that uses an extremely low amount of energy. So there might be even like so we can look for like 7B parameter models. Like this is a small one, but we would look for, there's a few models out there which are like 5 billion parameters, 7 billion, 2 billion parameters. And those ones you could use for these where you're very limited on memory. Someone else asked a question, which LLM is better to train an AI model which can convert speech to text and from text to ISL using 3D animated model, which was created using Unity? Okay, wow, interesting question. So, okay, I would think about this. I would maybe break this down into a few different tasks. So there are models which can handle speech natively, although I think probably still the easiest way to do this would be doing it as a separate step. So OpenAI has a model called Whisper, which converts speech to text. And text to ISL, I'm assuming that's a 3D shape format. Um, you could use a bunch of different models for that. But actually, if I were you, I would have to say you should try this out on yourself. You should test this out yourself. Test it using GPT-4, test using Claude, and test using Llama, and see how that works for you. Someone else said, using the LLMs in our project, they'll perform well if you fine tune it. Only way to know that is to try that and to measure it for yourself. Oftentimes, you can get very, very far without fine tuning as well. So back to the code after that little brief segue for the questions. This code that we just set up here, it just initializes the client, which is connected to Open Router. And then we have another line of code, specifies the model that we want to use, which I've copied. If I go to Open Router here, and I go to Llama Maverick, and I copied this ID here, and I've pasted it there. All right, and I think you need the free one. This is not the free one, but it's almost exactly the same one, but it's free, and it has slightly different limits, and so that's why it's free. But I've just accidentally closed my tab there. Here it is. So there's the model. So I paste that in here. And then for messages, you have to use this format, role user. You could also put in role system, or if you're talking about the history of the chat and you want to actually show a chat message that previously came from the AI and you want to include that in the memory, then you would put assistant. But since this message is coming from me, the user, or the user of the application, we say role user. And you can have a whole list or a history of all of the chat messages in the chat history that gets fed to the AI model each time. So after we run that, we will get the answer. All right. So, and this is coming from Llama 4. All right. So you can see that some sea turtles live up to 100 years, which is pretty cool. All right. So that's just the first example. We're going to go on to some more interesting things. Do we have any questions about this very fundamental example regarding how to use a LLM from how to use Llama through a free API? Any questions? Let's see. Great. I see some pictures. Looks like everything's going great. Cool. All right. Was anyone able to get this code working? So the next thing that I'm going to show. Okay, so Eric said, where do you write the prompts? All right. So important thing to understand when you are using an LLM through code is that all of the text that goes into the LLM is the prompt. That's why in this diagram, I just have prompt, arrow, llama, and then arrow, and then text output. So there's one big prompt going in, and then text coming out. And this prompt that goes in is actually a combination of everything that is of the prompt, the user input, the chat history, um, memory, image input. All of that gets combined into one prompt that goes into the LLM. All input is the prompt. Now, if you want to add additional prompts, you can. So I could put a prompt here saying, respond in French. How old do sea turtles grow to be? And so that has changed the output of the LLM, and I can combine this in different ways. I could separate this in my code. I could put a prompt here like this, and I could add that in like this. I could also add this as a separate message in the history here, right? And so I could put this prompt separately. These are all slight variations. I could actually make this a system prompt, which makes it slightly more, which weights it a little higher in importance. These are all ways that you can do prompt engineering through the API. Yeah, and as far as this question, how you can create animations of a 3D avatar using an LLM, that's a bit specific. So, but what you can do is you can use the LLM to generate code, which then is the animation, right? So this output here, this text output, it can be code, right? And so that code could be JavaScript code. It could be um, it could be animation in CSS. It could be Unity code. So any type of animation which can be controlled by code, you can prompt the LLM to generate that. And then you need to use more code in order to read the output of the LLM and then to actually run that. So I hope that's helpful. But that might be something that you need to dig a little deeper on. Yeah, send me a message actually, and maybe we could play around with it. That sounds fun. So yeah, let's do another example that's a little bit more interesting. Let's do image inputs. All right. So before, when we were looking at the inputs that were tokens to the LLM, you saw that groups of characters became tokens as the LLM reads them, as the LLM understands them, right? And this is how the LLM is trained. It's trained on these tokens. Now, another type of LLM was developed where images can also be broken down into tokens. And then the text tokens and the image tokens can be combined together and then passed into the LLM as input. Now, fortunately, you don't have to worry about how that tokenization happens. There is an API that you can use, which is standard, which allows you to pass images into the LLM as input. So what would that be useful for? It could be useful for all sorts of tasks. I could use it to identify plants out in my garden. I could use it to watch images from a security camera and detect if there's a threat. So there's all sorts of like really interesting uses and really cool applications of vision LLMs. So let's copy this code here and let's run that. So just paste that. And we don't have to change anything right now. We can actually just run it and see how it goes. Let's see. Okay, so I didn't show you the image that I passed in. We can see that here. Copying this URL here. This is the image that I passed into the LLM. And I also gave it a prompt saying, what's in this image, all right? And the output of that is the image depicts a group of 5 dachshunds sitting in a gray wicker chair in an outdoor setting. Amazing, right? So it's able to actually take text and image as input and then text as output. That shows that it really understands what's going on in this image. And we can we can say we can say something more interesting, tell a story about what's happening in this image, right? You're not limited to just asking it to identify, but here it's written a whole story about the characters there in the image. So it truly does sort of have some kind of understanding about what's in the image. So let's go through this code. Let me know if I'm going too fast. You can also, if something doesn't make sense as I'm going through, you can also sort of rewind on the stream as well, which is a feature that I really like, to go back and rewatch part of it. But this code is really simple to the last code that I showed you. So this is the same. This is the same, right? And there's a couple new things here. What is this? So what I've done here is I'm downloading the image using the Python requests library. Okay, it's a library that allows you to download web pages, files over HTTP, over the web. And then I've used base64, which is a way to encode any kind of file data as a string, and then turn that into a string that can be passed into the OpenRouter API. So what we end up doing here is giving it passing in an array of content into the API. And don't worry too much about this format here. This is very arbitrary. This is just something that was invented for the purpose of the API. It doesn't have a lot of meaning. But here we passing in an array. In that array, we have a text component, what's happening in the image, and we have an image URL. But that image URL is really just the data. It's really just a specific format where we have converted this image that we downloaded into a string, and we passing that string into the LLM. That's all. The reason why I show it this way is because I want to show you that if you have an image file on your computer, that you can pass that to the LLM as well. So Okay, we have a question here. Okay, someone asked how they could contact me. Yeah, you can just look under my. You can just look on my YouTube channel. My username on my YouTube channel is the same on every other social network as well. So you can find me on Twitter or LinkedIn. And then the question of why is it that the output of the prompt and mine is the same as it just picks up the random content? I don't understand the question actually. Your output of the prompt and mine is the same as it just picks up the random content. Actually, I can't understand uh, what's happening. So let's see. Okay. Um, Now, I wanted to do this to show you that you can do this with any image file that you have, but there actually should be a shortcut for this. If this is a JPEG or a PNG file, um, I think there's actually a shortcut here where you can actually just pass this in directly, and then the API will automatically download the file for you. This doesn't always work with every API, so be careful. But this shortcut where you basically just pass in the URL um, sometimes works. So that's a simpler way to do it sometimes. But be warned, this is a shortcut, and it has to be implemented in the API. Cool. So we've been so far through a couple of examples. One is we're using normal llama, and the next one we're using here the llama with vision. See, this guy's got the glasses on. All right. Now um, let's do another example. All right. Unless there's more questions on this topic. Let's see. Okay, well let's go to the next example. Um, okay, here we have a llama with a tool belt, and this is where things start to get a little bit crazy. Okay, so so far we've just dealt with text and we've dealt with images, right? Um, so now we're going to actually use the LLM to make decisions, and to do what's referred to as tool calling. So basically, making actions. And when you do this, it's sometimes called an AI agent. All right. So um, let me take this code here, which is similar but different, and put that in the Colab notebook. All right. So in this example, I've given a prompt here to the LLM, and forget about this. I'll come back to this huge uh, huge block of code in a minute, but I want to focus on here the prompt. And Open Router is completely different from React Router. So don't get confused there. It's just a router, meaning it can route to hundreds or thousands of different models from the same API. That's what it means by router. So um, I wanted to have an LLM that can solve math problems. All right, and you might even want to have an LLM that can do multiple tasks. Um, actually, let's do something a little bit more interesting. Okay, let's say that I wanted to have a smart house. Like, let's say I wanted to control my entire house with artificial intelligence. All right. So, and I wanted to be able to just speak to my house. Let's say I'm speaking to Amazon Alexa, and just the house will be able to do things for me, right? So, let's say I'm gonna say to the house, the grass outside is looking dry. Okay, and I want to have the house be able to actually take some actions. All right. So one of those actions might be, and let me just delete some stuff here because it's not necessary. Let's say water the lawn. Okay. So turn on the outside sprinkler. So what I'm doing is I'm basically going to use this sort of as an AI, sort of like how with Amazon Alexa, I can ask Alexa to turn off the lights, turn up the music, to do certain things, and it will just understand, right? So let's see if this code understands um, what I'm asking it to do. All right. So I said the grass outside is looking dry, and it has said water lawn, right? But we could give it, but in this code here, we can give it a whole bunch of different actions, right? So so watering the lawn was one tool, right? But let's say another one might be adjusting the lights, right? So let's give it actually another tool here. I'm going to copy and paste this chunk here. That should work. All right. So let's call this one here. Deleting the calculator example again. I'm just going to say adjust lights, and then set the living room lights brightness to a value, brightness. And then this one will have a property, an argument, which is a number. And I'm going to say this is brightness between 1 and 100. Okay, so I've done this. I've just coded this live, and it's a little bit messy, as you can tell. This schema, actually, it's very messy, and it's very hard to read. And I apologize, but I did not come up with this. I did not come up with this schema. Here, and you see, I'm already making mistakes. So this should be brightness, right? There's a lot of things going on here, right? If you want to understand better what all of this is, first of all, good luck. It doesn't make that much sense, but you can go to here. You can look for OpenAI tool use. You can Google this, and you'll come up with function calling, and you can have some more example code here that talks about tool use. But the main way to think about it is the way that that I think is best to think about it is, imagine that you have your LLM here, right? And so I've shown here, do you have the llama, all right? The prompt and the tools go in, and then the tool call comes out. But the way you should think about it is that you have some text. You have some text that comes in, right? Which is really the user prompt. And that comes into your program. And then in my case, my program is going to decide one of two things. It's either it might water the lawn, it might change the lights. It's also possible to have another option where, here, let me scoot that over. Can I scoot this? I can scoot it over here. Yeah, there we go. There's also possible to have it do nothing. And we can also write a program that after it does this, it goes in a loop, right? So I can ask it to do multiple things, right? So so this is basically the type of program that I'm writing now, and I'm using this tool called code to do that. So I defined the functions that I want: adjust lights, water lawn, by copying and pasting this template code. And so here I said the grass is looking dry. All right, so it's decided to water the lawn. But let's say it's time for bed. Let's see. Okay, now in this case, there's an error because there was no function. It decided to do this one, nothing. Okay, and in my code, I didn't write it. I didn't write a case for that. All right. So let's do something else. Let's say turn off the lights. Okay. And oh, it still didn't. In this case, it still didn't come up with. It still didn't give a tool call, which is pretty interesting, because I expected here set the lights to low. Oh, interesting. Okay, so now it's done it. So this tool calling feature is not it's not the most easy thing to do for an LLM to do. It often gets the wrong answer. It often doesn't understand what it's supposed to do. Here, I've had it to specify brightness as a number, and it didn't specify that. So maybe I should adjust this, where 100 is the brightest. I'm not sure. I may have to experiment with this in order to get it to work. So we can add as many different tool calls as we want here, and we can do something a little bit more useful as well. So, for example, I could write a code that allows the program to check the weather, or check stocks, or it could download a website, and you can do all sorts of different actions by implementing tool calls. Now, I've done a video. If this is interesting for you, I've done a video which is much more in depth on this topic. All right, called building an agent in Python from scratch. All right, and the code is here. The code is here too. So in this code, I've gone through an example where we define a function to get the weather. All right. Let's see what this is using. This is using a not Open Router, but a different provider. So, for example, this is using a function to get the weather. All right, and another one to calculate a math equation. And so we asked this, in this case, we asked the LLM, what's the weather in France today? And it decided to call the check weather function and use the city name Paris, right? So, and then we defined a separate function that would get that weather, and it was able to do that and then integrate it back into the output of the LLM. So I think this is sort of the next level for what a lot of you all are learning. This is maybe a little bit more advanced. But if this is making sense to you, if everything's making sense to you so far, I'd really encourage you to go watch this video about building agents from scratch in Python. Now, the last topic that I want to go over today is a little bit about what's called RAG, or basically basically using AI to search a database of information without fine-tuning a model. So we don't need to fine-tune a model to add in additional useful information. So let's just look through everything we've learned today so far. We've learned how to make a simple text generation call to an LLM. All right. We've learned how to pass text and images to an LLM and ask what's in this image, or have it generate text based on the output based on the image that was passed into it. And we've learned about tool use, which is a more advanced feature that you can use to make very complex and intelligent programs using LLMs. So let's talk a little bit about vector database. Has anyone heard of or used vector databases before? So I want to show how you can make a program that will search through a database of text, but uses machine learning and natural language to find the most relevant entry. So the example that I'm gonna give is here. I have an example here, and I'm gonna copy and paste that into Colab. And for this one, I've actually used here. Let me do it in this notebook. And for this one, I could not do it with OpenRouter. I couldn't do it with a free service, so I had to use OpenAI. So if you don't have an OpenAI key, I'm sorry, just follow along. But what we're going to do is we're going to search through our own database, and in this simple example, our database is just going to be a list. It's just going to be a list of strings, and we're going to search for a query. We're going to use a query to search this list. Now, let me come up with let me come up really quickly with something more interesting. I think it would be more interesting to do maybe some recipes. So let's do recipes here. I have a bunch of entries here. Let's say I'm making a database of Italian food, right? And let's add a few more. Let's make it even more interesting. All right. So let's say I have this huge list of different recipes, right? And let's say I want to search for spicy. All right, spice. Okay, and now we're not using, now to answer this question, we're not using a database in this example. We're just using a list in Python. Okay. Now you can do this with a database, but I want to show the most simple way to do it without a database. All right. And so let's say I want to search for spice, right? So one of these has spice in it, but some others, they might have spice in them, but they use a different word for it, right? So so black pepper, for example, is a spice, right? That's right here, right? So black pepper is in one of these, and basically we want to be able to search using AI in a way that it's not just a simple word search, but it's actually doing it in a smarter way. So to do that, we are going to use something called vector embeddings. Now, vector embedding takes each one of these strings and it turns it into a vector. So basically a list, an array of numbers, which means something about the text. And so the reason why I put this image here, because you can also think, the way I think about a vector is I think about these keys, okay? And a vector is really just a list of numbers. And when you look at this key, you can think of every location on the key. It has sort of a bump. It has these different bumps, right? And sometimes the key is thinner, and sometimes it's thicker. So you could actually use a vector, a list of numbers, to describe the shape of the key, right? See what I'm getting at? And each of these keys could be described as a different vector, right? So this might be 0, 0, 100, 50, or this would be 0, 0, 0, 0, 0. See what I'm saying? And each of these vectors would be the same length, but each one would be different. And so what a vector embedding is it's basically turning text with meaning into numbers. And then when we want to do a search, we're just looking at all of the different vectors that we have in our list or our database, and we're finding the ones that are the most similar. There's a equation to do that, which is called cosine similarity. But you can also just think of that equation as fitting a lock into a key and seeing how well does it fit. So let's run this, and I need to give it access to my OpenAI API key, right? And I also need to, did I skip a line? I also need to import from OpenAI, import OpenAI. Okay. From OpenAI. I've just run this code earlier, right? So from OpenAI, import OpenAI, like this. From, oh, no, my bad. I must have run it like this, import OpenAI. Okay. And so people here are asking in the chat about vector embedding databases, right? So before we even talk about databases, I mean, everyone here knows how a database works, right? Or has a rough idea of what a database is, you know? Let's talk about, so I'm not going to go over databases, but I'm going to explain the new part, which is vector embeddings. That's what's new, really. So, to go through this example, what we've done is I've got a whole list of recipes, right? And I've got a query. So the query might be something like, give me some spice, you know? And this will be interesting. So the first, when I just put it in spice, it said chicken tikka masala, but that was a good query already. Spice. The top one was chicken tikka masala, which makes sense because it's spicy, and it even has the word spice in it. But that's not how the search works. And then here it did shakshuka, and then under that it did vegetable pad thai. But what I want to show you here is, how do I do this? If I open this, here, what I want to show you here is that each one of these has a score, okay? So it's not a true or false search. It's not like it's filtering. When we're comparing one of these vectors to another vector, we always get a number between 0 and 1, all right? And that's just like comparing the key to another key, or comparing a key to a lock. Does it fit perfectly, or does it fit not at all, or does it fit sort of well, or almost? So someone had asked, we want vegetarian only, right? So let's say if I write vegetarian, this will be quite interesting. Now keep in mind, it's not a true or false search. It's a ranking. So if something is mostly vegetarian, that should come up towards the top. And we got, no surprise, we have the vegetable pad thai to start out. Then we had the eggplant parmesan and the butternut squash risotto. Now, let's go the other way. Let's test this. Let's go the other way and let's put in meat. And keep in mind, none of this text has the word meat in it, right? But it might have something else. The top result is beef stroganoff. And actually, there wasn't anything else. There wasn't really anything else with meat. So that's the best. That's the best that it could do. And if I would put in, this is fun actually. If I put in, Indian food, Indian good, Indian food. I hope the chicken tikka masala would come up, right? All right. So let's go through the code for this example. We have made the list of dishes, of dish descriptions. Great question. How is beef related to meat? Yeah, I gotcha. To meat in terms of vectors, right? That's a great question, and I'll get to that in just a minute. So we define a list of dishes, and then we're converting in this next step. We're converting those strings, just plain strings, into vectors. And you can the way that this works is like you can think of it as using part of an LLM. It doesn't convert text to text, because what an LLM is doing is it's converting text into numbers into text, right? Everything in the hidden layers of the LLM is numbers. So in a way, we're taking the first, you can think of it as taking the first half or part of an LLM and using that to convert this text into numbers. And we can look at those here, what those look like. And it's a huge amount. It creates a very, very long list of numbers, which is the vector, which is one vector for one of these. So, and let's just look at the first one, right? And we can see how long that is. So each one of these becomes an enormous vector of 1,500 numbers. So that would be an extremely long key, but it still would be, you can still think of it like that. And then we're taking this query and we're also turning that into a vector. And then what we're doing is we are, just imagine that these are the keys, and this is a lock. Or you could think of it the other way around. It doesn't really matter. And then we're trying each key in the lock, and we're seeing which one fits the best. And then we're just sorting it. The rest of it is just the sort code, sorting it by which one fits the best. And so to get to your question, how is beef related to meat in terms of vectors? Well, if you think of vectors in 2 dimensions, right? Like in 2 dimensions, or even in 3 dimensions, um, those vectors would be closer together. They would be closer together than many, many other words, um, like vegetable or train or orange, right? Those vectors should be closer together. Now, the thing is that these vectors are not in 2 dimensions or 3 dimensions, which is as much as a person can visualize, but they are in um, 1500 dimensions, which is more than a person can really visualize. But they are close together, and there is, if you go to this link that I have here about transformers and how LMs work, they also discuss using embeddings, and they give some more really cool visuals about how language becomes a vector. So yeah, that was the last example. Now let's just talk a little bit about how you could combine some of these things together to make an AI application. Um, so one of the very, very first questions that someone asked in the workshop was, how do we reduce hallucinations? Well, one thing we could do is we could use this code to create a whole database of useful information, and then when someone wants to call the LLM, we could search this database using the query, and then we could take the output and we could add that into the prompt of the LLM, thereby um, augmenting augmenting the prompt, the query, the information that goes into the LM, and providing it with information that we know is accurate because we entered it into our database, and that's called retrieval augmented generation. And there's many other techniques that you can use in order to make your AI systems more accurate and more effective. So for the rest of the workshop that we have about 10 minutes. I'm starting to lose my voice a little bit, so I'd like to just hear, are there any questions? And if you're watching this live from a classroom, you can also pass your question on to the organizer, who can text it to me, or you can even or you can type it directly into the chat. But I'd love to just take the last 10 minutes to answer some questions and hear about what kind of topics you'd like to explore more. What are the things that you think I explained well? What parts do you think I didn't explain very well? It's a little bit difficult teaching in this way because I can't see you, so and I can't see your screens. So I don't know which parts I've explained correctly, and I don't even know how many of you are are watching this. Might be watching this in the classroom right now. All right. So one question was, how can we get our database connected to the LLMs? So what I had just tried to explain just now using the vector embeddings here in this example is that essentially I showed you how to connect a list of items. These don't have to be strings. They could be. You could even use images here. You could make embeddings out of that. And how you could connect this to an LLM. I haven't shown the final step where you connect this to the LLM. So I could show you how to do that, but essentially we would just have another step after this where the output here and this query get combined together, and then you pass that again into the LLM. So the way that looks like here is you would have something like query, right? And then we have vector search like this, right? Can we see this? Yep. We have vector search. Oops, I got lost here, right? And then we have the output, right? In this case, we actually had, someone's trying to help me. In this case, we actually had multiple search queries. You can choose how many. You can choose how many results that you want to select, right? And then from there, what we can actually do is take this output, pass that into the LLM, and then you can also pass the original query as well. So here I had asked it for like, give me some spicy food, right? Then what we should expect to see if we take these results and the original query and then pass that into LLM, we should expect to get something like a well-formatted answer that tells me, oh, if you're looking for spicy food, you might want to try a chicken tikka masala. Otherwise, or if you're looking for something vegetarian, maybe you can go for a pad thai. And so those two together, the vector search and the LLM, make what many people have found to be a really effective approach. And I showed how to do this using a list in Python, but a database is just a persistent list, right? So a vector database is just the same thing as what I've written here in the code, but it's a database. There's no other practical difference aside from it being the performance of it. Let's talk about. So that's how you would get the database connected to LLM. And then we had one question here saying, is it closer to a graph, or is that a different technique? Oh, I'm so glad that helped you to understand it. Is this similar to a graph? A graph would be a different type of data structure, because this is a list or a table, really. This is tabular data. It has no, there's no relationships between the items in the database. When you're talking about a graph, then the items in the database are linked together. So a graph you could think about would be maybe like your friends in a social network, or all of the people in a social network are connected by who they are connected to or who they are friends with. So Facebook, all the friends of everyone on Facebook, that would be a graph, for example. And there are other techniques that use graphs, and you can use trees, you can use many data structures to augment your LLMs. Let's see. Okay, let's see. Yeah, I just got a message from Pavan saying we're just about to wrap up, which is perfect. Perfect timing for me. Yeah, this is the first time I taught this level. I have a lot more videos about a little bit more advanced topics. So if you go here to my channel and then you go to playlists, you can go to AI Agent Camp. These ones, the AI Foundations is about machine learning and deep learning in general. So that's way more foundational. But if you want to learn about AI engineering, I really recommend this AI Agent Camp. That we had many people watch it, and it was a really great time. And it basically talks about the same type of things that I talked about today, but many levels deeper. And there's also some really cool demos in there. You get to see using AI to write code. You get to see using AI to scrape web pages, and even like operate a computer, all using LLMs. So basically, taking what we did today and making it even more intelligent, basically what you end up with is AI agents. Great. So yeah, we just have a minute left. Yeah, he's been when he gets needy, he tries to type on the keyboard too. So he's watching and he's learning how to code, aren't you? Yeah. So we have one more in the back. I think he's asleep actually. Yeah. This one is paying attention. So yeah, that's all. Thanks everyone, and you can find me. You can find me on my website or on my YouTube. My LinkedIn and everything is the same that I have here. So you can just look me up if you have any additional questions. So yeah, thank you so much, and thank you for having me. If you build something from what we did today, please send it to me or post it on Twitter and tag me. I'd love to see what everyone is building. Great, and enjoy the next session, and see you next time.